Turbine locomotives had enormous horsepower, and that's exactly why railroads rejected them. On paper, turbine locomotives should have won. They were smoother than piston steam engines. They could produce massive, continuous power. Some designs pushed beyond 8,000 horsepower, numbers that made even the big boy look conservative. If railroads were only about power, turbine locomotives would still be running today. But railroads don't operate on paper. They operate on schedules, fuel bills, maintenance hours. And one rule that matters more than any horsepower number: if it doesn't work every day, it doesn't work at all. By the late 1940s, steam locomotives were reaching their limits. They were powerful but expensive to keep running. Diesel locomotives were emerging, but early models didn't yet dominate in raw performance. Railroads wanted a solution that could keep steam alive, but make it better. And turbines looked like the perfect answer. In power plants and ships, steam turbines were already proven. They ran smoothly. They delivered steady output. They avoided the violent back-and-forth motion of pistons. Engineers believed turbines could fix steam's biggest problems. No hammer blow on the track. No massive moving rods, just clean rotational power. The idea made sense, until turbines met real railroad work. Freight trains do not operate at steady speed. They spend much of their time starting from rest, pulling heavy loads at low speed, creeping through yards, climbing grades where speed drops and torque matters most. And this is where turbines immediately struggled. Steam turbines are happiest when spinning fast. They are inefficient and sluggish at low speed. A turbine can deliver impressive power, but only after it gets moving. Railroads don't need power that shows up later. They need power that shows up immediately. Diesel locomotives did exactly that. They produced strong pulling force from a standstill. No spin-up, no delay, just torque. To compensate, turbine locomotives required extra systems: complex gearboxes, electrical transmission, additional cooling. Every solution added weight. Every solution added heat. Every solution added something that could break. Meanwhile, diesel-electric locomotives solved the same problem naturally. The diesel engine produced torque at low speed. The electric traction motors delivered it directly to the rails. Simple, effective, reliable. Then came fuel consumption. Turbine locomotives were extremely thirsty. To maintain their output, they required enormous amounts of energy just to keep steam pressure stable. Fuel consumption climbed quickly, often faster than usable output. Railroads noticed this immediately. A turbine locomotive could move a train, but it moved that train at a cost that made every mile more expensive. Diesel locomotives told a very different story. They used less fuel per ton-mile. Their consumption stayed predictable, and their efficiency held up across a wide range of operating conditions. For a railroad running thousands of trains every year, predictability matters more than peak performance. Maintenance widened the gap even further. Turbines require precision, clean systems, tight tolerances, specialized inspection. Railroad shops were not built for precision machinery. They were built for rugged equipment and fast turnaround. Every turbine locomotive became a special case. When something failed, it didn't fail gracefully, it failed expensively. Downtime increased. Maintenance hours climbed. Availability dropped. Diesel locomotives were the opposite. They tolerated dirt. They tolerated wear. They tolerated imperfect conditions. When something broke, crews knew how to fix it. And if one unit went down, the rest of the consist kept moving. Railroads think in fleets, not individual machines. A turbine locomotive was one massive, complex system. A diesel consist was modular. Lose one diesel, and the train slowed down. Lose a turbine, and the train stopped. Railroads hate single points of failure, and that became the deciding factor. It didn't matter how powerful a locomotive was if it wasn't available when needed. Diesel locomotives spent more time moving freight. Turbine locomotives spent more time in shops. Over months and years, that difference became impossible to ignore. And once railroads compared operating cost per mile, the debate was effectively over. Turbine locomotives cost more to fuel, they cost more to maintain, and they delivered fewer productive hours. Diesel locomotives did the opposite. Lower operating costs, higher availability, consistent performance. At that point, the decision stopped being emotional. Railroads are not museums, they are businesses. They don't choose the most impressive machine. They choose the machine that works every day. That reality explains why turbine locomotives never recovered. Once diesel-electric locomotives proved they could handle everyday railroad work better, there was no reason to keep experimenting. Not because turbines were useless, but because they solved the wrong problem. Railroads didn't need the highest horsepower ever recorded. They needed locomotives that could deliver usable power hour after hour without surprises. Diesel locomotives fit that need almost perfectly. They weren't flashy. They didn't break records. They didn't look dramatic in photographs. But they showed up every day, and reliability compounds. A locomotive that runs reliably today is more likely to run reliably tomorrow. Crews learn how it behaves. Maintenance teams learn its weak points. Spare parts stay consistent. Over time, the entire railroad system adapts around that predictability. Turbine locomotives never reached that stage. They remained experimental machines in an industry that had already moved past experimentation. And this is where turbine locomotives truly lost the race. They weren't beaten by one fatal flaw. There was no single catastrophic mistake. Instead, they lost through a collection of small disadvantages. Slightly worse fuel efficiency, slightly longer maintenance downtime, slightly lower availability. Any one of those could have been tolerated. All of them together could not. Diesel locomotives won because they were good enough in every category, and excellent in the ones that mattered most. That's a difficult truth for engineers. Because turbine locomotives were impressive machines, they represented ambition. They represented creativity. They represented the desire to push technology as far as possible. But railroads are not impressed by ambition. They are impressed by results. A freight railroad measures success in ton-miles moved per dollar spent, not in horsepower records, not in elegance of design. Once diesel locomotives began improving year after year, turbine locomotives were effectively trapped. To compete, turbines needed to become more efficient, more reliable, and easier to maintain. But improving any one of those areas required adding complexity, and complexity was already their biggest weakness. Meanwhile, diesel technology improved without increasing operational risk. Better engines, better generators, better traction motors. Each improvement made diesel locomotives stronger without making them harder to operate. That gap never closed. Eventually, turbine locomotives weren't just less attractive. They were irrelevant. And what's fascinating is how quickly the industry forgot them. Some turbine locomotives operated for only a few years. Some were scrapped shortly after testing. They weren't preserved because they didn't represent a future anyone wanted to remember. They represented a path that railroads explored and rejected. But that doesn't make them pointless. Turbine locomotives taught railroads exactly where the limits were. They proved that steam technology had reached the edge of practicality. They showed that pushing harder didn't always move the industry forward. And they delivered a lesson that extends far beyond railroads. Engineering success is not about maximizing one variable. It's about balance, power, efficiency, reliability, cost, maintainability. Ignore that balance and no amount of brilliance will save the design. That lesson didn't end with steam. You see it everywhere. In aircraft design, in automotive engineering, in software systems. The most powerful solution rarely wins. The solution that fits the system does. Turbine locomotives didn't fail because engineers were wrong. They failed because the problem changed. Railroads stopped asking, how powerful can we make this? And started asking, how consistently can this move freight? Once that question changed, the answer was no longer steam. It was diesel. And once diesel won that argument, turbine locomotives quietly faded into history. Not as failures, but as reminders. Reminders that progress isn't about pushing harder. It's about choosing smarter. And in the next video, we'll break down exactly how diesel locomotives won that decision. Not in theory, not in marketing, but in dollars, downtime, and real railroad economics.